I am Venkata Rao, Professor of Mechanical Engineering, IARE, Hyderabad. Now I will discuss about the topic Knapsack problem. Topics to be covered: introduction, classification, mathematical formulation, 0-1 knapsack problem, examples, fractional knapsack problem, examples. The knapsack problem is a combinatorial optimization problem. In this, a number of objects will be given and a knapsack of capacity will be given. The objects are having weights. The weights will also be given, and each object has some value. The values also be given. Then the problem is to keep the objects in the knapsack so that the total value of the items placed or objects placed in the knapsack will be maximum, and the sum of the weights of the objects placed in the knapsack should be less than the capacity of the knapsack or equal. The knapsack may be a bag or a box or a container. Suppose n number of objects are there and the weights of the objects are W1, W2, W3, Wn, so on, and the values of the objects are V1, V2, V3 and so on, and the capacity of the knapsack is W. Then the problem is to maximize the sigma VA into Xi, I is equal to 1 to n, subject to the constraints sigma WA into Xi, where I is equal to 1 to n should be less than or equal to W. That is the capacity of the bag or knapsack. Then classification. The knapsack problem is a two types. One is the fractional knapsack problem and another one is 0-1 knapsack problem. So in the fractional knapsack problem, the items are divisible. That means, for example, if you take 5 kgs of sugar and 10 kgs of jaggery and 20 kgs of atta, like that. In that case, we can divide that objects for 2 kg or 3 kg or 4 kg or 5 kg, like that you can divide. So that is, in this, the objects are divisible. But in case of 0-1 knapsack problem, the objects are not divisible. That means, suppose if you consider the items like ACs, refrigerators and washing machines, etc. Suppose we want to keep these objects in the container, we cannot divide those objects. Suppose if the objects are divisible, the problem is called as the fractional knapsack problem. Otherwise, the problem is called as the knapsack, 0-1 knapsack problem. So, in the 0-1 knapsack problem can be solved by using effectively by the dynamic programming problem, whereas the fractional knapsack problem will be solved effectively by the greedy method. So, next, mathematical formulation of knapsack problem. Suppose n objects are there and a bag or container or knapsack, in that the object I has weight Wi to be placed. Let Va is the value of the object I and capacity of the bag is W. The value Vi into Xi can be obtained if an object I is placed in the bag. The objective is to maximize the total value of the objects placed in the bag, that is sigma Vi into Xi, I is equal to 1 to n, subject to the constraint sigma Wi into Xi, J is equal to I is equal to 1 to n should be less than or equal to W. The problem can be represented as maximize sigma Xi is equal to sigma Vi into Xi, Xi is equal to 1 to n, subject to the constraints sigma W into Xi, I is equal to 1 to n should be less than or equal to W. For fractional knapsack problem, we can also write 0 less than or equal to Xi less than or equal to 1. For 0-1 knapsack problem, Xi may be either 0 or 1. Now consider the problem of 01X problem. Consider the following container loading problem. Total capacity of the knapsack is 8, number of weights are 4, and profits are 1, 2, 5, 6, and weights are 2, 3, 4, 5. That means the object 1, for the object 1, profit is 1 and weight of that object is 2 kg. For this object 2, profit is 2 rupees and the weight of the object is 3 kgs. For object 3, the profit is 5 rupees, the weight of the object is 4 kg. And object 4, the profit is 6 rupees and weight of the object is 5 kg. Now, by using the dynamic programming, we can find out the solution. So, for that, this tabular form is very much useful. So, profit in RS, weight in kg, object included, and the weights 0, 1 up to 8, the maximum capacity is 8. Now, when no object is included, then 0, this is 0, 0, 0, 0, 0, 0, 0, 0, 0. Next, when first object is included, then here the profit corresponding to the first object is 1 and the weight of that is 2. So, this profit 1 is possible only when the weight inserted is 2 kg. Then, here when the weight is 0, there is no profit. This is 0. When it is 2, then the profit is 1. The profit is 1. Then, when the weight is 3, so the profit will be 1 only. Here 1, 1, 1, 1, 1, 1. Next, when the second object is included, then weight of the object is 3 kg and the profit is 2 rupees. Profit is 2 rupees. Now, so for 0 weight, no profit. For 1 also, no profit. When the weight is 2, then this is 1. Next, when the weight is 3, then the profit is 2 kg. Weight is 4, his profit is only 2 kg. When the weight is 5, that means both the objects are included. The weight of the first object is 2 kg and the weight of the second object is 3 kg. Total is 5 kg, so that we will get the total profit of 3. Then again 6 kg, only 3, and here also 3 whole. Next, when the third object is also included, then the weight of the third object is 4 kg and the profit is 5. The profit is 5. Now, when 0, this is also 0. When weight is 2, only 1. Weight is 3, this is 2. When the weight is 4, then it becomes 5. When weight is 4, the profit is 5. When weight is 5, then again the profit is only 5. When weight is 6, so we can consider the first and the third. 4 plus 2 is 6 kg and the profit is 6. And then when the weight is 7, 3 plus 4 can be considered, that is 7, and 8 also, okay, 7 only. Then coming to the fourth object, when fourth object is included, then the weight of the fourth object is 5 rupees, weight of the is 5 kg and the corresponding profit is 6. Then here again 0, 0, when the weight is 2, 1, when weight is 3, this is 2, when weight is 4, the profit is 5. So weight is 5, when the weight is 5, then the profit is, so when the weight is 5, so the profit is 6. When the weight is 6 kg, now you can consider 4 plus 2. 4 plus 2 is 6, here also 6, and if you could put 5 also, again you will get 6. When it is 7, 5 plus 2, 7, or 3 plus 4 also 7, you can get 7. And when the weight is 8, when the 8 is 8, then you can put 5 plus 3 is 8 kg, 6 plus 2 is 8. So that we are getting the maximum of 8 in the last. Now the same thing is represented here. So first one 0 0 0, second row when the first object is included we got 0 0 1 1 1 only. When the second object is included, then the weight is 2, then only the profit is 2. After that 2 and 5, when it is 5 you can put both the objects so that the profit will be 3 3 3. Then when the third object is included, then when the weight is 4 kg, the profit is 5. Then 5 kg also 5 6 7 like that. When the fourth object is included, then it is 6 6 7 8. Now you can use the formula to finding out the values. Now you see the formula is V of I comma W. I is the object, W is the weight of the object. In that we have to consider maximum of V of I minus 1 W comma V of I minus 1 comma W minus I plus profit corresponding to that object. So you can use this formula for finding out the values. Now suppose if 4 1, that means if the fourth object is included, then we can calculate corresponding to the first column, that is V of 3 of 1, V of 3 comma 1 minus 5, profit is 6 is equal to 0. How it is 0? V of 3 of 1 or V of 3 1 minus 5, 1 minus 4 is 1 minus 5 is minus 4. So this is undefined. We cannot see the negative values here. So that this option can be eliminated. The corresponding to the first option 3 of 1. What is the value corresponding to this 3 of 1? So object weight is 3 kg and corresponding to the 1 the value is 0 only. So that we are getting 0 value. Now corresponding to this negative values will be there corresponding to 4 2 4 3 4 4. So that we can eliminate that one. Next we can consider 4 of 5. V 4 of 5, 4 comma 5 is equal to maximum of 3 comma 5. Weight is 5, I minus 1, 4 minus 1 is 3. So that V of 3 comma 5 comma V of 3 comma 5 minus 5. 5 minus 5 means 0. Now you can see what is the value of 3 comma 5. Now you can see what is the value of 3 comma 5. So 3 comma 5. So the value is 3 comma 5 or 3 comma 0. 3 comma 0 is 0 only, that is 6, and 3 comma 5 is, so 3 comma 5 is 5. That means one is 5, another one is 6. In that we have to consider the maximum value, so that this is 6. Next 4 comma 6. In that we have to take the maximum of 3 comma 6 comma 3 comma 6 minus 5 plus 5 plus 6. This is also again 6. V of 3 of 6 is equal to 6. V of 3 of 6 is equal to 6, and 3 of 3 comma 6 minus 5. 3 of 1 is again 0, so that this is 6. Both are 6, so we can consider 6 only. Then next coming to the 4 comma 7. 4 comma 7 is equal to maximum of V of 3 comma 7 comma V of 3 comma 7 minus 5. So in this 3 comma 7 is 7 only, 3 comma 7 is 7 only, and 3 comma 2 is 1 only. So that again we are getting 7, 1 plus 6, 7. Both are 7s. You can consider any one of it, maximum of it, so that is 7. Next, the last element is 4 comma 8. Maximum of 3 comma 8 comma V of 3 comma 8 minus 5. So in this case, V of 3 comma 8 is, V of 3 comma 8 is 7. now you see v 3 comma 7 is 3 comma 8 is 7, and this one v of 3 comma 3, 8 minus 5 is 3 plus 6. Here the value is 2. 2 plus 6 is 8. Total profit is 8. Now, what are the objects included in the bag? Now, see, the maximum profit is 8. This maximum profit 8 corresponding to the inclusion of the object 4. When remaining profit after removing the object 4 is 8 minus 6, that is 2. Now check whether 2 is there, in the previous row. So here the maximum profit is 8. This profit 8 corresponding to the inclusion of the object 4. So the profit corresponding to the object 4 is 6. Now subtract this 6 from 8. 8 minus 6 is the 2. Now check whether 2 is there in the previous row. Yes, 2 is there in the previous row. Now again check up. This 2 is there in the previous row. Again this 2 is there in the third row. That means this profit 2 is not corresponding to the object 3. So this 2 may be the profit corresponding to the second object. Now check up whether 2 is there in the second row. Yes, there is no 2 in the second row. That indicates that this profit is corresponding to the object 2 only. So that means object 2 is included. Now after removing this 2 from the profit 2, the balance is 0. Now check up whether 0 is there in the previous row. Yes, 0 is there. Now check up whether 0 is there in the previous row. That means 0 is there. That means object 1 is not included. So what are the objects included here? The second object and the fourth objects are included. The solution is x2 is equal to 2, x4 is equal to 6. The remaining are zeros only. The solution, the maximum profit is 8. Now, consider the another problem where the total weight of the bag is 8 kgs. Number of weights are 5. So, profits are 3, 4, 1, 2, 6 and weights are 2, 4, 3, 5, 5. The profit corresponding to the first object is 3 and the weight is 2. Second object is, the profit corresponding to the second object is 4 and the weight is 4. The profit corresponding to the third object is 1 and the weight is 3 kg. The profit corresponding to the fourth object is 2 and the weight is 5. And profit corresponding to fifth object is 6 and the weight is 5. Now, how to find out the solutions? So, in the same way, when there is no object, that means no object is included, then the corresponding profits are 0, 0, 0, 0, 0, 0, 0. Now, when first object is included, the weight of that object is 2 and the profit is 3. The profit is 3. Now, here, you see here 0 only. So, when the weight is 0, when the profit is now 1 means again 0. Again 0. When it is 2, when weight is 2, the profit is 3. Then weight is 3, the profit is 3 only. So that you can fill up this row by 3. Next. When the second object is included, it is 4 weight. This is profit is also 4. Second object is included, the profit is also 4. Now, when the weight is 0, no profit. When the weight is 1, it is 0. When the weight is 2, it is 3. When the weight is 3, also it is 3 only. When the weight is 4, now when the weight is 4, the profit is 4. Then weight is 5. When the weight is 5, the profit is only 4. When the weight is 6, means we can include both, then the profit will be 7. So the profit is 7 in these cases. Okay. Next, when the third object is included, what is the weight of the third object? That is 3, and the profit is only 1. Now, so corresponding to 0 weight, no profit. Corresponding to 1, no profit. When weight is 2, the profit is 3. When the weight is 3, again you can consider this only because the profit is more, so that this is 3. When the weight is 4, you can consider weight is 4, so this is the profit 4. When the weight is 5, you can consider the first object and third object, that is 5, but that is 5. And fourth object itself we are getting 4. Any one you can include it, so that it is only 4 only. It is 4 only. Then weight is 6. When the weight is 6, we can include the first object and second object. The profit will be 7. First and second, the profit will be 7. And when it is 7 kg, 4 plus 3 is 5 only. 4 plus 2, 6. The profit is 7. So that it is 7. And when the weight is 8, 2 plus 4 plus 3 is 6 plus 3, 9. But here we are getting only 7. But when the weight is 9, you can add all the 3, so that you are getting 8 here. So actually we should not, total capacity is 8 kg. That means you should not consider this 9th one, because the weight is only maximum weight. You can consider only 8. This is 7 only. Next, then coming to the inclusion of the next object, that is fourth object. When it is fourth object, a fourth object is included, so then the profit is 2, the weight is 5, profit is 2. Then you can see here it is 0 only, 0. When the weight is 2, it is 3. When the weight is 3, this is weight is 3, you can consider this, that is 3. When the weight is 4, you are getting only 4 only. Then where weight is 5, when the weight is 5, here it is only 2. When the weight is 5, you can consider 3 plus 2 or this one, that is 4 only. Then when the weight is 6, you can get 7 here. When the weight is 7, 5 plus 2 or 4 plus 3, you can consider that is only 7 only. Then the weight is 5, then weight is 7 is over, then weight is 8. So when the weight is 8, you can consider this, which one we have to consider? Weight 5 plus 3, 8. 4 plus 3 is 7 only. 4 plus 2, 6. So that we are getting the maximum profit is 7. You can see that. Now here, total capacity is 8 kg. So this is the profit. Then we can get like this. So Wi 00003, and then weight included. Weight included is this one. So the maximum is only 8 only. So that cannot consider this. Here when it is 8, you are getting this is 9. Next. So now you see this maximum profit. What are the objects included? So the maximum profit is 9 you are getting. This 9 is corresponding to inclusion of the object 6. So the object is inclusion of the object 6. So when you subtract this 5, then you are getting 4. Now check up whether 4 is there in the previous case. So the 4 is there in the previous case. Again you check up whether 4 is there in the previous row. Yes, it is there. And next you can find out whether the 4 is there in this. That means you can check up here x x6 is 1, and that means 6 object is placed, and x1 is included. X1 is included means that is second object. X2 is included, then the profit is 4. This is corresponding to the profit. 4 is there. So when you subtract the profit means 4 is there here, that is corresponding to the previous one, whether the 4 is there or not, whether 4 is there in this. So that means this is the inclusion of the object 2. That means x2 2 corresponding that one 4 is there. Now check up whether 4 is there in the previous case. 4 is not there. That means this 4 is only corresponding to the x2. Then if you subtract this one, we are getting 3. 4 minus 4. So what are the things you included here is, so the included articles are x6, that is x6 is there, that is 5, and then x3 is equal to 4, so that you are getting the profits like this. So then coming to the fractional knapsack problem. Consider the following container loading problem. Total capacity is 15 kg. Number of objects are 7. Profits are 10, 5, 15, 7, 6, 18, 3, and weights are 2, 3, 5, 7, 1, 4, 1. The weights are 2, 3, 5, 7, 1, 4, 1. That means for the first object, the profit is 10, weight is 2. For the second object, profit is 5, weight is 3. For the third object, profit is 15, weight is 3. For the fourth object, profit is 7, weight is 7. And the fifth object, profit is 6, weight is 1. For the sixth object, profit is 18 and weight is 4. And the last object, profit is 3, weight is 1. In this, the objects are divisible 1. That means we can take the fractional values also. So first, fractional knapsack problem. So considering the profits, only. So that means we are considering highest profit object first, and next highest one we consider next, like that we are doing. So in this you see the highest profit is 18, that is corresponding to the object 6. That means object selected is 6. What is the weight of that object? Weight of the object is 4 kg. What is the capacity? Capacity of the capacity is 15 kg. So the total capacity of the knapsack is 15 kg. So that weight is 4 kg. You subtract that one, so that you are getting 11 kg. So how much profit you are getting? Profit you are getting is 18. The total profit is 8 after inclusion of the sixth object in the bag or knapsack. Then next highest profit is 15. That is corresponding to the third object, and the weight of the third object is 5. The weight of the third object is 5, and capacity is, so 11 minus 5 is 6. Then the profit corresponding to this is 15, and what is the total profit is 33. 18 plus 15 is 33. So after 15, what is the next highest profit? 10. That is corresponding to the first object. Then weight of the first object is 2, and the balance is 4, capacity of the bag left over. Then the profit is 10. Then this is 43. Then next highest profit is 7. That is corresponding to the fourth object. So now fourth object is placed here. Then coming to the fourth object, we actually the capacity is only 4, but here the weight of the fourth object is 7 kg. So that means we cannot consider the entire weight. We can consider only the part of it. That means we want to consider only 4 kg only. So that this becomes 4 minus 4, 0. And the profit 7 by 7 means 1 rupee corresponding to 1 kg. So that it is 4, and the total profit is 47. So if you consider the weight, considering the highest profit first. Considering high profit objects first. Then now you see the same thing is written here, so that you are getting the maximum profit. That means when the sixth object is included, the capacity of the bag is 11, profit is 18, total profit is 18. When the third object is included, the weight of the third object is 5 and capacity leftover is 6, profit is 15, this is 33. Next, the first object is included, weight is 2 and capacity leftover is 4 and profit is 10 and then total profit is 43. The last one, fourth object is included, only part of that is included, that is 4 kgs only, the capacity is 0 left 0 here, then the profit is 4, so that total profit is 47 when it is considered high profit objects first. Next, considering low weight objects, considering low weight objects, considering low weight objects, considering smaller weighing objects. Now, the object 7 is 1 kg, object 5 is 1 kg, object 1 is 2 kg. So that means first we have to consider the low weight objects or smaller objects first, smaller weight objects first. So first consider 5. The weight object selected is 5, weight is only 1, the total capacity leftover is 14 and the profit is only 6. Profit is 6, the total profit is 6 here. Then coming to the next lowest is 1, that is corresponding to the job 7 or that is object 7, the weight is 1, the capacity leftover is 13 and the profit is corresponding to the 7th object, the profit is 3, so that this is 9. Then next is 2, object selected is next lowest is 1, next lowest is the object 1. So object 1 is having 2 kg, so object 1 is selected and the weight is 2, the balance is 13 minus 2 is 11 and the profit corresponding to that is 10 and the total profit is 10 plus 9 is 19. Next lowest is 3, that is corresponding to the second job, so that 3 you can consider, this is 8, 11 minus 3 is 8 and the profit corresponding to the second one is 5, this is 24. 19 plus 5 is 24. Next, after 3, 4, the job is 6 here, the job is selected is 6 and the weight of that 6 job is 4 kg and the profit capacity is 4 kg and the profit is 8, so that this is 18 plus 24 is 42. 18 plus 24 is 42. So next, after selecting this 5 is the next lowest or smallest object, so that you can select the object 3 and the weight of that object is 5 kg, but we cannot consider this 5 kg because only 4 kgs are left over here, so that we can consider only 4 and this becomes 0 and the corresponding 4 we have to find out the profit. So what is that profit? That is 12 only, so that you are getting 54. 0.8 kgs we are considering. What is the solution? X1 is equal to 1, that means fully included. X2 entire object is included. X3 only 0.8% of the object is included. X4 is not included. X5 is fully included. X6 is included. X7 is included and the total profit is 54. Suppose if you consider by selecting the low weight objects, we can keep more weights so that we can get the profit of 54. Next. So next one is the greedy method. It is the best method, we can say. By seeing the profit, we can also say it is the best method. So in the greedy method, we are not considering the high profit items or not considering the low weight items, but we are considering the items based on the highest profit by weight ratio. Highest profit by weight ratio. That means we have to find out the profit by weight ratios. Corresponding to the first object, profit is 10, weight is 2. 10 by 2 is 5. For the second object, profit is 5, weight is 3. 5 by 3 is 1.66. Then the third object, profit is 15 and weight is 3. 15 by 5 is 3. For the fourth object, profit is 7, weight is 7. So it is 7 by 7 is 1. For the fifth object, the profit is 6, weight is 1. The ratio is 6 by 1 is 6. Then next sixth object, the profit is 18, weight is 4. So 18 by 4 is 4.5. And seventh object, profit is 3, weight is 1 and the ratio is 3. So in this case, we have to consider the highest ratio items first. Highest ratio items first. In this problem, the ratio is more corresponding to the fifth object. The ratio is 6 corresponding to the fifth, and then first object, and then sixth object, and then third object. Like that we have to consider. Now, so the weight ratio is more corresponding to the fifth object. So fifth object is selected. The weight of the fifth object is how much? Fifth object weight is 1. Then capacity. So total capacity is 15 kg. 15 minus 1 is 14. So profit corresponding to this fifth object is, profit corresponding to this one is 6. So total profit is 6. So next highest ratio is 5. That is corresponding to the first job. So first job is included. Then the weight of the first job is 2 and the balance weight is 12 and the profit is 10, so that it is 16. Then next coming to the next lowest, that is 4.5. So that is corresponding to the sixth one and the weight of that is 4 and 12 minus 4 is 8 and the profit is 18 and this is 34. 18 plus 16 is 34. Next, coming to the 4.5 is over. Then coming to the 3. So 3 means this is corresponding to the third job, third object. So weight of that third object is 5 kg. Then we can put here the balance is 3 kg and the profit is corresponding to this is 15. So that this is 49. 49. Then coming to the next, this 3 is over. Then we can consider this one. This one is 3. So that the object 7 is included here and the weight is only 1 kg and the weight is 1 kg. So that it is 2. Then coming to this profit corresponding to this is 3 and this is 52. Then last we can consider 1.66, that is corresponding to the second job. Then what is the weight of the second job? The weight of the second job is 3 kg, but we cannot consider that entire 3 kg. We want only the 2 kg, so that we can consider 2 kg, so that it becomes 0. And the profit is, now you can find out that profit 2 by 3 of profit ratio here. So that 2 into 1.66, 2 into 1.66, that is 3.2, so that we are getting 55.2. So like that we can find out the profits, and we should know how to select the objects by using this greedy method. So in the previous case we got the profit is only 54, before that it is only 47. So in this case we are getting 55.2. That means by using the greedy method we can select the objects in a better way. Now consider the another problem. So consider the following container loading problem. Total capacity is 100 kgs. Now number of objects are 5. The profits are 20, 30, 66, 40, 60. weights are 10, 20, 30, 40, 50. Now, first one, considering the high profits. Considering the high profits. So the profit is maximum corresponding to the third object. So that the third object is selected. So in this case, we are considering the high profits and then we are finding out the solution. So weight of that third job is 30 kg. And then capacity available. So the total weight of the bag is 100. So the balance is only 70 kg. The profit is 66 and total profit is 66. Next highest profit is 60. So that is corresponding to the fifth job. We can consider that, but the weight is 50. So 70 minus 50 is 20 here and the profit is 60. So this is 126. Next highest profit is 40. That is corresponding to the fourth object. The weight is 40, but we cannot completely utilize that because only 20 kg is left over. 20 kg is left over, and then we can find out the profit here. So 20 kg, weight is 20, so that it is 40. So this is how much we can utilize. This is 70. 50 minus 70 minus 50 is 20. In this we can put only 20, so that this is becomes 0. We are utilized only x. We can by using high profit. High profit is 40, so that it is 20. So that it is 20 only. So that we are getting 146. 146 we are getting here. This is only, so object x1 is not included. Considering high profit, x1 is not included, x2 is not included, x3 is 1, x4 is equal to 0.5 and x5 is 1, x5 is 1, x5 is 1, x5 is 1, x4 is 0.5. The total profit is 146. So like that we can find out the solution. So here this is 20 only. In that case we can get 146, and in this solution x1 is equal to 0, x2 is equal to 0, x3 is 1, x4 is 0.5, x5 is 1, and the total profit is 146. Then considering smaller weight objects first. So which one is having smaller weight? 10, 20, 30, 40, 50. So first you consider the first job, and the weight is 10 kg, capacity is 90 kg, and the profit is 20, and the total profit is 20. Next, considering next one is second. So the weight is 20. So this is 70, and the profit is corresponding to this one 30. So that you are getting 50. Now consider the third job. Third job is 30, and third job is 30. So that it is 40, and the profit is 66, 116. Then coming to the fourth job. Fourth job is 40, but here 40 is there, so that 40 can utilize, and the profit is 40, so that it is 156. So we are getting 156 here. Then x1 is 1, x2 is 1, x3 is 1, x4 is also 1. So 10, 20, 30, 40 and 40 is 0. So that x5 is 0. x4 is equal to 1. So that the profit is 156. So the profit is 156. 40 we are utilizing. 40 means 156. So x4 is 1, x5 is 0. This is the solution for this. Next Now we can consider the greedy method. So this is the best method because the profit will be maximum. But in this case, we are considering the profit to weight ratios. Ratios. So for the first job, profit is 20, weight is 10. The ratio 20 by 10 is equal to 2. And for the second job, profit is 30 and weight is 20. 30 by 20 is 1.5. Then third object, where profit is 66 and weight is 30, the ratio is 2.2. And fourth object, profit is 40, weight is 40, the ratio is 1. And fifth object, profit is 60, weight is 50, the ratio is 1.2. Now, we have to consider the highest ratio. Highest ratio is 2.2, that is corresponding to the object 3. So, weight of that object is 30 kg and the capacity available is 70 and profit is 66 and total profit is 66. Then, coming to the next ratio is 1.5, that is corresponding to the next ratio is 2, that is corresponding to the first object. Then the weight of that first one is 10 kg only, 10 kg, and this is 60. Then the profit is 20, this is 86. So 10, profit is 20, 86. Next, coming to the ratio 1.5, that is corresponding to the second job. The weight is 20, this is 40 only. Then the profit is how much corresponding to this second job? Profit is 30, that is 116. Then coming to the 1.5 is over 1.2, that is the fifth job, and weight is 50 kg, but we cannot go for that. That is only 40, so that this becomes 0, and so we can find out how much profit it is. How much we are utilizing? We are utilizing 40 kg. So that is corresponding to the 50. 50. This is 60. Profit is 60. So profit is 60 and weight is 50. So 1.2. 1.2 into this 40. 48 we are getting. So that this is 164. The total profit is 164. So now you can see the same thing. So when third object is included, capacity is 70, profit is 66 and again 66. When the first object is included, this is 60 only and profit is 20, this is 86. When the second object is included, weight is 20, capacity is 40, profit is 30, 116. When the fifth object is included, only 40 kg can be considered and the profit is 48 and total profit is 164. So the solution is x1 is 1, x2 is 1, x3 is 1 and x4, there is fourth object is not included. Fifth object is included only 80% of that, so that the total profit is 164. So now you see in the greedy method, highest value. So greedy method is best method for finding out the solution of fractional knapsack type problems. The other methods are there, but they may be easy. But here we want to find out the best solution, means we have to go for the greedy method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.